Hi, this is Dermot Gregory from the University of Vermont, presenting for the TIDC Poster Competition 2020. I'm a master's student in mechanical engineering with advisor Professor Driver Houston. This poster is about high performance concrete with post-tensioning shrinking fibers. Um, so for some background and introduction, concrete failure is often catastrophic because concrete has a very high compression strength, which means it's loaded highly, but it's brittle. Um, and additionally, nature is a big detriment to concrete. It's one of the biggest opponents of concrete. Um, Freeze thaw cycles as well as salt can degrade concrete, expand cracks, they weaken structures and supports. Concrete's very widely used. The goal of this research is to develop high performance concrete with these post cure active pre stressing fibers. They shrink after the concrete is cured to cause a pre stressing or a pre compression uh, on the concrete um, so that when it's then loaded, the compression can take some of that load and it increases the strength of the concrete overall. Um, so the current focus or the current way we do this is with steel rings, which are held open with PVA, which we'll talk about later, and also with steel springs. And the sort of next phase of this is using chitosan fibers. Chitosan is a fiber that shrinks in high pH environments, alkaline environments such as concrete, which makes it a good option for pre-stressing the concrete. Um, so some background on the experimental design and data collection. The testing was a 4-point bending flexural test with a supporting span of 200 millimeters and a loading span of 66 millimeters. Um, Steel rings were added to the concrete mixture in volume ratios of 1/2 and 1%. Um, each test used two constant displacement rates of 0.03 inches per minute and 0.15 inches per minute, and a 100 hertz sampling rate um, for the force over time, and then also acoustic emission monitoring, measuring cracks uh, during the test or during the course of the test was also used. So the sort of for the mechanics of the shrinking fibers, the rings were held open with this water-soluble 3D printing filament, PVA, um, and then in concrete, which has a lot of water in it, the PVA will dissolve, leaving the springs sort of stretched open and wanting to close. For the springs were held open with the mold, and the concrete was poured around the springs, which were stretched open, and then the supports holding the springs open were removed. So then the spring is being held open in the concrete and wanting to pull itself back together and close. And for the controls for each, for the control for those steel rings, just the steel rings were used just without any PVA installed holding them open. They were just closed steel rings to act as, essentially post shrunk uh, rings. And then springs were added to the concrete uh, without being held open in their natural state, which did not induce any pre-stressing. Um, so from, I'll zoom in here on figure 2. So with the pre-stressed steel rings, we can see that it's a little hard to see from here how we did with the stress and before failure, but the post-failure ductility is greatly increased with the pre-stress group relative to the control group. Um, as well as with the springs, we increase post-failure ductility, which is helpful after things like catastrophic failures. And for the overall strength, we can see that the pre-stress ring relative to the control, the failure strength in megapascals is about half a megapascal higher. And then we really don't see a difference between the pre-stressed and control spring groups. Um, and then coming down here to the acoustic emission data. Um, so figure D and E, or figure D and F are the control groups, and figure E and G on the right-hand side are the pre-stress groups. And so you can see kind of in both uh, this top row and this bottom row, the control groups saw significantly less um, acoustic emissions events or cracks relative to the pre-stress group. The pre-stress group showed a lot higher, um, a larger number of acoustic emission events and cracks at relatively the same amplitudes and distribution, as you can see down here. And for this final figure, figure 3, we're just showing an example of a ring pre-stressed held open with that soluble 3D printing filament PVA, as well as a picture of actual chitosan fibers to be used in the future, and then a picture of the experiment post failure of the block used. And so I think that's everything. Special thanks is given to Zhuang Li, who greatly assisted in testing and concrete specimen preparation, as well as Robert Worley II, who assisted with acoustic emission monitoring. This work would not have been possible without them, so we thank them greatly. Yeah, and I think that's all that I have to cover for today. Thank you very much for your time. Bye.